Other applications of Taylor polynomials to physics and engineering are explored in exercises that follow and in an applied project in a later video. And I'm not doing that video and that project in this video because we'll take a few more hours. Anyway, so exercises, let's go look at exercise 1. So Taylor derivatives show that Tn and f have the same derivatives at a up to order n. So in other words, just for all derivatives, it's always going to be the same when you take the derivative of the Taylor approximation and the function f. So we can see that the Taylor polynomial and all of its derivatives cancel out all the terms except the first term at x equals a, thus equating to f and its derivatives. And what I mean by that is, let's just take a look at this. So let's just write the general Taylor polynomial expression. So t sub n of x equals to f of a, so it's at a plus f prime of a at, then multiplied by x minus a, power of 1. Next one's going to be f double prime, like that. So f double prime of a, x minus a, like that. And then, yeah, this is going to be divide this by 2 factorial. 2 factorial, this is going to be now, or I'll just fix that up, put this over here, 2 factorial, then just put this by itself, x minus a to the power of 2. Next one's going to be plus f triple prime at a divided by 3 factorial. Now it's going to be x to the 3, and there's not enough room there, so we're going to go plus dot dot dot, plus, then I'll go all the way to the nth one, so fn of a divided by n factorial. Now we're going to have a x to the n, like that. So yeah, this goes all the way to over here. So this is the t sub n Taylor polynomial. So now if we look at this one, now if you take the first value, we're going to show that it equals to f. So tn, I'm just going to put an arrow like this, or put it over here. So where do we put it? Yeah, so the first one, or just put it like this. So t n at a, when you plug in a, these all cancel. This a minus a is 0, a minus a squared is 0, and this one is not x to the n, this is x to the a power of n, like that. So when you plug in a inside, this goes to 0, it vanishes. So what we get is this all goes to 0, so it goes f of a. So this one is equal to its derivative, or equals to its 0th derivative. So it can be considered as its 0th derivative. So it states show that t sub n and f have the same derivatives at a up to order n. So this is order 0. So this is correct. Now the next one, if we take the derivative, so now t n prime of x equals to derivative of f of a is a constant, that's 0. This is a constant 0. This one's going to be, well, this is x minus a, derivative is just 1, so it becomes f prime of a, like that. And plus, plus this is going to be now, this 2 goes down. Okay, so it becomes 2 over 2 factorial. And this is going to be just a constant f double prime of a. And then times it by x minus a, and then power of 1. So you subtract the power. The next one's going to be plus, this 3 goes down. Yeah, just put the 3 down, just moved it over. So 3 over 3 prime of factorial. Now it's going to be f triple prime of a times it by x squared. So minus the power using just the power laws. And then make more space, so plus dot 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 plus f sub, f the nth derivative at a divided by n factorial, but then this xn goes down, so the n power goes down, we're taking the derivative, so let's just write that a bit better. So the n goes down, and then we're still going to have our nth derivative at a, and then now it's going to be times it by x minus a, then n minus 1, so we subtract the power, it's using basic power laws, and now when we plug in t n of a at a, inside everything else vanishes but the first term. So as I stated here, everything vanishes except the first term. So all the derivatives cancel out, all the terms except the first term at x equals a, thus equating to f and its derivatives. So here's equates to f. This one's going to be, this can be by itself. So all of these just vanish, and we're just left with f prime of a. So we got this one's correct. Now the next one, take the derivative again. So t sub n double prime of x. This goes to 0. Now take the derivative. This one just is 1. And this is a 2 over 2. 2 factorial is just 2. So that's just going to be Yeah, it's going to be, well, just for completeness, just put this 1 down. So put the 1 down, and then x minus a to the power of 0 is just 1. So it just vanishes. So in other words, we get a 2 factorial over a 2 factorial. And then we get a f double prime at a. And now the next one's going to be plus. Now this 2 goes down, so 3 times 2. And then over 3 factorial. And then this is going to be f triple prime at a of x. And also, I forgot to do, I keep making a mistake. This is going to be x minus a squared. This is going to be x minus a squared. It's squared like that. And there's not enough room there. I'm just going to put over here plus dot 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 plus. And now the next one's going to be n. And now n minus 1. N minus 1 goes down. N minus 1 over n factorial. Like that. And then we're going to have a f and a, so that's just a constant, all stays the same. Now the power rule again, this subtracts 1, n minus 1 minus 1 is minus 2. Like that. So that's what we get. And then when we plug in a inside this one, so we get t, this double prime. Let's write this better. T sub n double prime at a equals 2. And now plug this inside. Yeah, these ones all, this is just cancels, becomes f double prime of a. Then all these other ones cancel. This a minus a is 0, a minus a, power of n minus 2 is still 0. So this is it. So that's equal to its derivative. And now the next one is, let's keep going. 1, 2, 3 of x. This equals 2. Take the derivative again. These are just constants. It goes to 0. This one here, and also this one's going to be a 1. So you have to subtract a power, so that this 2 goes there and then subtracts the power. So yes, my bad for making that many mistakes in a row. So anyways, well, as long as they're corrected still. So this is going to be 3 times 2 times 1. It's going to be just 3 factorial when you take this 1 down. Regardless, it's the same thing. So 3 factorial, and then f triple prime of a, and then this power of 0, that's just, it just vanishes, equals to 1. And then plus, dot dot dot, plus, the next one's going to be n, and you can see the pattern, n minus 1. This power goes down, n minus 2. All over n factorial. And this is going to be our f n at a. Like that. Let's write this better. F n at a. And this is going to be x minus a, power of n minus 3. Alright, so now continuing further, you can plug this inside. Again, you're going to get the exact same thing. You can see the pattern. F triple prime at a. This factorials cancel, and we're just left with f triple prime at a. That's equals the same thing over there. So then, yeah, this becomes this check mark. That's correct. And now, yeah, now do the last one just to see the pattern. It's going to be now dot 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 all the way up to t of nth derivative, t sub n of nth derivative at x. This equals 2. All right, let's do this again. This equals 2. Yeah, so this the nth derivative. As you can see, the 3 is going to go down. It's going to keep going down until you get to 1. So in other words, until it gets to n, which is equals to x minus a power of n minus n is 1, and then even further than that. No, actually, I mean n minus n is 0. So it gets to the 0, and that becomes the whole thing equals to 1. So you're eventually going to get to, and you can see the patterns. This is going to get to n factorial over n factorial. Yeah, this is going to be f of a. Yeah, this is going to be f nth derivative at a, like that. And then you plug this inside. Is going to be t sub n equals to, this is at a. Yeah, it's just equal to that. So the nth derivative is just equal to that. The n's cancel. Okay, so at any value is going to be the same thing because you've removed every other term. Like that. And check mark.